we're not gatekeepers. We can be convinced that these buildings are safe. Just show us, and we'll understand.
Most project teams don't know how to have the mass timber conversation with skeptical fire departments. And even if they do, it still goes wrong because by the time that meeting happens, it's usually too late to matter. Today's episode is a conversation between two people who spent their careers on opposite sides of that table. Erich Roden spent 34 years in the fire department, finishing as a deputy chief. He served on the UL Fire Safety Research Institute, where they burned a lot of CLT, and he sat on the Wisconsin Mass Timber Task Force that helped build the Variance pathway for the Ascent, the tallest mass timber building in the world at the time. Mason Brandt is the president of WoodCore Engineering with 25 plus mass timber projects under his belt. And in this episode, he's the engineering voice on what fire performance actually requires at the connection and member level. So here's what we cover. For design and engineering teams, connection detailing and how the char rate drives member sizing, and why exposed steel is the failure point that keeps fire marshals up at night. For developers and owners, using the Ascent story as a blueprint, new land development brought the Milwaukee Fire Department into the conversation in the initial concept phase. And Erich breaks down exactly what that process looked like and why it's the reason the building got built the way it did. And for anyone taking mass timber into a new market, what's shifting with major metro departments like New York City? Why East Coast project pipelines are now almost double or triple that of West Coast? And what fire departments in unfamiliar markets actually need to see before they're comfortable saying yes. Because as Erich would say, fire departments aren't gatekeepers. They just want to be brought in early, shown the data, and convinced that their ability to fight fire won't be compromised. All right, let's get into it.
I've been I'm in my 34th year in the fire service, and I recently retired as a deputy chief for the city of Milwaukee Fire Department. My last role there was essentially a citywide shift commander where I was responsible for all field operations on a 24-hour period. And one of my favorite parts of my job, which was kind of a later in my career de facto position, was kind of the built environment building and fire protection system subject matter expert for the fire department. I'm not a fire protection engineer, and however, one of my bailiwicks coming up through the fire service was NFPA 1413 and a lot of the IBC stuff. So I was asked a lot to help out on some of the building renovations, new projects, and some of the other wonky questions that our Department of Neighborhood Services had, which is essentially our buildings department in the city of Milwaukee. So I'd advise on them. And again, like I said, it was actually one of my favorite parts of my job. I was able to get into these buildings, see what the latest and greatest stuff was, and some of the innovations that were coming into the built environment. But I've also been in the academic side. I was an editor-in-chief of a major firefighting trade magazine for a lot of years. So I was able to get around the country, travel a lot, and see how the other half lives and what they were building and how they were fighting fires in these buildings. I also serve on the advisory board of the Underwriters Laboratories Fire Safety Research Institute. We burned a lot of CLT, a lot of building the fire behavior and thermodynamics in these structures, and eliminated a lot of the fallacies and urban legends we can talk about later in the fire service with regards to how fire impacts wood and cellulose material and the like. Oh, and most recently I served on Mass Timber Task Force for the state of Wisconsin. We developed a document which is essentially a way to codify tall mass timber in the state of Wisconsin and provide a pathway for variances, because like the Ascent building we'll talk about in a moment. A lot of these grandiose projects will likely seek the variance process to do a lot of cool things to these buildings and make them more aesthetically pleasing and such. So this provides a better pathway for those developers and engineers and fire departments to get these buildings built.
For sure. So thank you for unpacking your background there a little bit. Question that I would have for you is, before you got all the way through to the end of all this different testing and involved in those task force, like, what was your your peers in the fire departments in the fire world's perspective on mass timber, and like how do you think that's changed from maybe initial assumptions to today?
That's a really good question. So I like to start my shop worn joke. Firefighters hate two things: change and the way things are. Right. So we historically, we only fought fires in, type 4 buildings, especially in the city of Milwaukee. It's a post-industrial city, had a lot of manufacturing, a lot of those types of buildings present. A lot of them are still standing to this very day. And we also had true dimensional lumber, private dwellings, your 2.5-story old colonials, Victorians, and the like. So that was kind of our bread and butter fire buildings. And then we were kind of, thrown for a loop in the 1970s with the advent of lightweight wood construction, TGI beams, wood trusses, gusset plates. And that gave us a lot of fits in the fire service. We had a lot of fatalities, and, unfortunately, we're very parochial. So a lot of the experiences we learn, spreads across the country, and we kind of, believe what we tell each other. And we have a lot of warnings and stuff that we pass along. And one of those was don't trust the truss was kind of the adage that was pervasive throughout the fire service for 30 years. Even to this day, it's still being used. And that was as a result of the Walbaum's fire, I believe in 1966 in the city of New York. They used bowstring trusses, and one of those trusses failed, causing 12 firefighters to plunge into the fire building and subsequently lose their lives. So that spread like wildfire, no pun intended, across the fire service that all trusses are bad. And there was a similar fire in Hackensack, New Jersey. So these fires started compounding, and the stories started in the academics in the fire service really gave the wood industry a bad shake at that time. So when we fast forward to the current mass timber and type 4 structures, A through C, and heavy timber, there's kind of a lack of trust endemically in the fire service with these buildings. Obviously, a lot of the firefighters, actually every firefighter for the most part, today wasn't around when those buildings were built. We're not getting as many fires as we used to in those buildings, but we still get a lot of them. And usually the soundbite you hear after one of those fires is, I can't believe what a shellacking that building took. It was a 5-alarm fire. You could see this fire from space, and the building's still standing. Well, that's in part due to the dimensional size of this lumber. But the stories really don't get passed around too much. They're not making the textbooks and the peer review articles and journals. And then along comes current CLT, NLT, a lot of the other panel and mass timber based construction principles that we're seeing now. And so there's that inherent distrust of the industry, right? The wood industry gave us lightweight wood construction years ago, and this is the next thing they're forcing on us. And as these buildings are being built, the fire service is kind of getting their nose under the tent to see how these things are built. And the Ascent was the epitome of how to do it right, and the winning recipe to get firefighters aware, versed, and trusting these buildings again.
Yeah, that makes a lot of sense. But I can see from historical engineered wood product innovation stumbles how you can carry that forward into like mass timber today. So knowing the background of kind of like perceptions in the fire industry, and we'll just call it wood-based construction, when you started getting involved with the testing, I guess specifically for mass timber, what did you find that perhaps surprised you or ran counter to the narrative for so long?
Well, one of my personal thoughts was, how are these things connected? What are the connection systems? What are, the current best practices for putting these things together, right? And I mean, if you look at, anything you own, use, whatever, anything made from more than one thing, it's how it's put together is determines the function and stability and quality of the thing, so to speak. And that was what we realized, especially the ATF studies. What they found was, shoddy craftsmanship on these connections caused some devastating, loss of connectivity of the structural members. Those that were, engineered within an inch of their life, like, the projects are today, you didn't see that. I mean, you saw the char layer and the prescriptive char layer, do what it's supposed to do. And, you kind of look at the data are correct. And the thermodynamics and the fire behavior is what we expected. And, these buildings hold up.
Mason, what would you say around like the current approach to the industry is, or maybe for those that are doing it, what I would say to like your guys' standard on connection design is like, what are you guys doing that can convey confidence into like the fire side of things?
That's a great question, Bree. Connection design a lot of times is driven by the code requirement for the build. When we look at buildings like Ascent, those kind of connections typically need a 2 or 3 hour rating, similar to what the concrete connection requirement would be on a building that size. On the lower scale, it really comes back to, as Eric said, how things are put together. If the connection is a steel bucket hanger, right, that's going to behave very similar to, it might be thicker steel that might behave similar to how we connect a TJI to a girder with a like H2 sedan, right? So if we're looking for fire performance out of the connections, we really don't want to see exposed steel, right? Steel behaves where it loses strength as it's heated. And that's where it's its failure point. It reaches a certain temperature that overcomes the steel's inherent strength to hold itself up, compared to wood, where wood maintains its strength by using wood fibers to resist those forces. And as wood burns away, it uses section. At a certain point, there's not enough wood section left to support the load it's carrying, and that's how it fails. So to give confidence, right, if you go into a building of type 4A, B, C construction that has a rating requirement, you're going to see all those openings and gaps in that connection sealed up, protected from any kind of fire attack. If you see exposed bolts, that's a piece where we should pay attention to how that connection has been performed.
Yeah. And I think all of these issues that we talked about get exponentially more important when you're building the world's tallest mass timber building, which is what you were involved with, Eric. Can you walk me through kind of how that whole journey started?
Yeah, I'll tell you, I jokingly call it a Cinderella story, but it really became that. I mean, I was I was a battalion chief at the time, and, I'm sitting in my battalion office, and I get a phone call from the fire chief secretary who said, hey, I need you to come downtown ASAP. We have a local developer that wants to build. At the time, it was a 23-story piece of wood, on one of the busiest avenues in the city of Milwaukee. The fire chief has a lot of concerns and questions. Could you come down and help him out? He says, you're the guy, right? So I kind of chuckled to myself because this was, close to the time of the ATF study, some of the UL stuff that was done. And a lot of the UL researchers were involved in those studies. And, we, poured over the data to look at that stuff because, we heard it was in town. We knew it was coming. So, we had a lot of eyes and good minds on it. So I gathered some of the things that I had on it at my disposal. And then I, quickly contacted Sean DeCrane, who worked for you all at the time, and some of the other fire service subject matter experts. Say, hey, is there anything new that I'm missing? And I got to head down and talk to the boss. So I want to act like I know what I'm talking about here. So I get downtown, and he has this proposal from New Land Development for a 23-story building on a concrete podium. And I quickly allayed a lot of his concerns and fears about how these things burn, because again, historically, this fire chief, like every other, most firefighters in the United States, were conditioned and raised on, wood is bad, it's going to burn, it's going to collapse. And, we've had, fires in the city of Milwaukee where firefighters immediately fell into basements because of, a burned away TGI beam. So, I'd explain the differences. I'd explain char layer, how the, CLT panels were made. And, when you put 5 of them together, here's what happens when they burn in. So he said, okay, well, the assistant chief and yourself will be going to a meeting at, Department of Neighborhood Services, and, definitely give me the scoop on that. So, this was, I believe, in 2018, fall of 2018. So the New Land Development and Corps of Architects, proposed this to the city, that they had, an idea of this, concept of the world's tallest mass timber building. And, they kind of shopped the project around a couple of conferences, I believe, and kind of got some industry support and some firepower, if you will, and eyes on the project. So, we go to this first meeting, and New Land had all the firepower in the mass industry, mass timber industry, I should say, in the room. You had David Barber, you had, Thornton Tomasetti, you had all the right people in the room. And it was kind of a cathartic moment because, I quickly realized, oh, this thing isn't in a permit yet. This thing is still, being penciled out. Why are we here now? And, that was kind of, the inverse of how the fire department's been involved with projects. Usually everything's done, signed, sealed, delivered, steak dinners ate and everything the night before to get approvals on everything. And then we kind of come in and give our 2 cents. And, if it meets code, there's really nothing we can say. Right. And, this is the opposite of that. They wanted to hear the fire department's concerns, thoughts, gripes, and kind of operational considerations. And, I quickly wiped the tears away because it was, like I said, it was kind of a, something we're not used to seeing. And beyond flattery, it was good because we kind of saw, everything that they were trying to do with the building. We knew they were going to pursue variances because at the time, the city was under the 2015 IBC. So this thing exceeded it by 1 million stories. Right. So, so we knew they were going to have, I thought, I don't know how this is going to get approved. It far exceeds the IBC and the city ordinances and whatnot, I should say. And so I'm like, yeah, they agreed to some of the concerns we had with the structure under construction that were already in the code. Sealing it up, 4 floors below, and no debris, no smoking and grilling and that kind of stuff. And we believed them. I mean, they were sincere, and it wasn't the typical boilerplate, slide over a folder with some schematics and drawings of the building. They were generally trying to convince us that no, they were going to do everything that they promised. And again, like I said, that's the last thing we ever heard at a lot of these meetings. And I don't mean to rag on developers too much. They're, they have jobs to do, but they're also used to a process too, where the fire department comes in later and whatnot. So, I was very pleasantly surprised that, with how quick we were brought in. So as the project progressed, they obviously were required to do some performance-based testing to exceed, the IBC and get the variances. And, I get a phone call, from, Jason Korb, the architect, says, "Hey, what are you doing on this day? We're all headed out to Madison to, burn a bunch of timbers." And I was, yeah, I'll go out there, check it out. And, professionally curious, and I was, personally curious as, oh man, they're going to throw 3,000 degrees at this thing for 3 hours. All right, we're going to find out for sure now. And so we went to Forest Product Labs in Madison, got a cool tour of the place and saw everything they're doing, and then walked over to the furnace, and sitting in there is one of the Austrian timbers that they were going to use for the Ascent. And they fired the thing up, came back a few hours later, and pulled the thing out. It chipped away the burn layer, and the thing still had, I believe, almost 100% of the structural integrity. So, and I mean, put my face into the sight glass, watching the jets burn this thing to smithereens, and it was an eye-opening moment of proof of concept and and proof and testing. These things burn the way they're prescribed. They the char layer did what it was supposed to do, and it still retained its structural integrity. So, me already being a believer in understanding the construction, I think, that was kind of a seminal moment for the fire service and, the developers and the city itself, that, yeah, this thing is going to hold up if it's on fire. And obviously 3,000 degrees for 3 hours is no fire we're going to allow firefighters to crawl into, for that long. And, we'll be pulling people out anyway. So that's a latent effect of firefighting efforts. So, the approvals were given. The one thing we did ask for was, more Gypcrete in the public hallways. And the owner of New Land Development kind of leaned over me and says, "Yeah, we agree with that. We want you guys to feel confident this building. We're going to give you the Gypcrete in the public hallways." And they were also going to add 2 more floors, so it's going to be 25 stories. And I heard Gypcrete in the public hallways because the stairwells and our public hallways are our beachhead to launch firefighting operations from. I said, no problem. Add 2 more stories. We're not going to refute that or fight it. So it became a 25-story building at that point. During construction, they offered unlimited inspections, drive-bys, site visits, and Chris Johansson from C.D. Smith, like I said at the Mass Timber Conference, should be in the Mass Timber Hall of Fame for what he did for us. He was the project manager of the Ascent, and gave no less than 1 million tours to Milwaukee firefighters to show them the building, how it was put together. And I mean, I have tons of pictures of my firefighters walking through the building, and they're just looking at this thing in awe of the amount of wood. And one of the seminal sound bites they had was, "Hey, chief, you know how much fire it would take to burn this amount of wood down?" I said, "Exactly." And so it was really good for them to see that, and obviously word of mouth spread across 36 firehouses in the city. Then everybody wanted to come down and see it. So we managed to get most firefighters through it. And we just had a great time. Guys, got to know Chris, and he knew the fire department. So the relationships not only with the developers, the architects, and the engineers of the building were amazing, but also the people building it. The iron workers that were putting these things together were showing us step by step how they sink a timber in, and they had they would torque the bolt in, and then the guy with the glue gun would come in right behind him, fill that with glue, and you couldn't interrupt him, because if he put too much or too little in, I mean, the whole thing was a mess. And how they shimmed up each floor every day. I mean, it was just an amazing story and process and build to be a part of. And I mean, even the crane operator was I believe he's a volunteer firefighter from where he came from. So there was a lot of that jocularity back and forth. He'd be on his radio talking down to us, and we'd be busting his chops. So, hey, how long does it take you to get up there? How many stops do you have to take to climb up there? And he would joke with us saying, "Hey, well, how come your helmets look so clean? Don't you guys get any fires here in the city?" So there's a lot of that back and forth. So, I mean, every like minute of that story was great. I mean, it was, I was actually, like a lot of firefighters and people in my administration, we were actually sad when it was finally finished, because we weren't able to stop by every day and hang out. But, it was just a great experience. And, at the end of the day, you realize, what a winning recipe that whole, approval process and build was, for, interagency relations, firefighters understanding, building engineering, MEP better. And, not necessarily having a say in that kind of stuff, but having a say in terms of, what's our role in approving this building, and and even just having general concern for our safety and well-being, and just a professional approval of it.
For sure. And this is kind of my own little talking point, but I always say that there's not necessarily like a lack of expertise or educational material or data. It's just a lack of awareness and exposure to what's happening, right? And I think you can hear that through your story. So we talked a lot about like the fire department, like looking at what the developer's doing, what the building's made out of, and kind of like understanding from like the design build ownership team what you guys are looking at. I think it would be pretty interesting to go in the reverse and say, like, how do you fight fire in a building, and why does that matter for how we design and build them?
Well, here's something interesting, and might alleviate some of the concerns some developers that are listening to this might have. We will fight fires the exact same way in a high-rise residential type 1A or type 1B structure, the same way we will in a high-rise residential mass timber building. So I'll give you a real quick synopsis of what we're thinking when we get there is, so we kind of have sections of the building that we prioritize when we arrive, but we always use that interior stairs of public hallways, again, is like our beachhead to launch our firefighting operations. We'll usually bring all our toys up and a hose and nozzles to the floor below the fire floor. We'll get off the elevator, several floors below, just for, safety factor. And we'll march up to the floor below. We'll kind of take a look at the fire floor, see if, the apartment door is open, and, do we have to charge our hose lines below or up on the fire floor itself. And, we just, bring all of our stuff there. We have all our equipment, and we'll prioritize the fire floor, the floor directly above the fire floor, and we'll start from the top floor, usually work down, just based on stack effect and some of the smoke movement within the structure. But again, like I said, it's the same principles and firefighting operations in these buildings as we would, conventional legacy type 1. But so that's what we're thinking. So, I mean, if developers kind of explain to the fire department, you are not going to have to change your firefighting operations. And I should say, as an aside, that we prefer, CIPC, stairwells. I know there's a big push to have mass timber stairwell construction. Obviously, it's not going to collapse readily, but just having that sense of security that we're operating from a concrete core is going to give us a lot of confidence in kind of hanging out in these buildings until we get the fire out versus considering pulling out or backing out at serious fires. And I'll also say these buildings are also required to be sprinklered within an inch of their life, so that is going to do the lion's share of the work before we even get there. So it's really us just making sure that the fire's out, the sprinkler heads did their job. We've deployed our personnel to essentially search for people because regardless of sprinkler activation, you're still going to have heavy smoke conditions. So that would be the main focus versus worrying about, the structural integrity of these buildings.
And I'll do a follow-up question, and I'll throw this one to you first, Mason. So if you're outside the industry, because a lot of public feedback and public officials that may not be fire experts or design experts, et cetera, have opinion and sway on like what gets done, whether through code environment, policy, all that kind of stuff. But when we're talking about ratings for buildings and like the safety and what that translates into, I think there's a little bit of a misconception that concrete or steel buildings don't burn, or that or in distinguishing like what the rating means. So it's if you have a 1, a 2, or a 3 hour rating, it doesn't mean that your building's not going to burn, but it's a safety metric for how long and what that means. Mason, could you unpack that a little bit for us first?
Historically, the stigma around wood and timber has been that wood's bad, wood burns, right? And the big issue with that is the wood adds fuel to the fire, where steel and concrete don't do that, right? They're non-combustible, they don't burn, but we don't always consider how they interact with the fire fully to understand if it's a better or more detrimental system. A few months ago, I got to sit through a webinar on One Meridian Plaza in Philadelphia. That fire was back in, I think, late 80s, early 90s. And it's one of the few instances where a high-rise was intentionally torn down because it was so damaged by fire. And it's one of the case studies that we use to support requiring full sprinkler systems in all high-rises that are constructed new. That fire, there was a sprinkler system put in by a tenant. It wasn't required by code. And that tenant sprinkler system was what eventually controlled the fire. It eliminated a lot of the idea that just because of steel and concrete, the building won't suffer structurally from a fire. The structural systems, the structural steel in that building were damaged to the point where a consulting engineer pretty much wrote the building off and said it couldn't be repaired. It had to be torn down. So One Meridian Plaza doesn't exist today in the city of Philadelphia. That was also a fire that the city of Philadelphia had a firefighter fatality on. So it's an impactful incident. I believe that fire burned for more than 12 hours before the fire department had to evacuate. And that kind of leads into the conversation of the rating and fire performance in building, right? Fire has a range of intensity, and how we evaluate fire performance, we have to set a standard fire somewhere. One of the big pushbacks from the fire services, today's fires don't follow that model of what a standard fire curve is in temperature and time. I continue to, the piece I continue to impart on the firefighters that I teach and talk to is, our fires are different. We have different fuels. A lot of our materials are synthetic. They burn hotter, they burn faster, right? But we have to compare these things based on some benchmark. So that's how the fire test curve is still relevant. It's still a relevant test that says, hey, if you have a 2-hour rated system, it has roughly double the fire resistance as a 1-hour rated system, right? It's not guaranteed to burn for 1 hour or for 2 hours and be strong. There are 2-hour rated systems that might only last 30 minutes, depending on the time and intensity and the exact situation, right? So there are tools we use to measure and compare how resistant the system is to a fire.
Got it. And Eric, when you were going through the Ascent process, you mentioned a 3-hour rating, but they hadn't tested that as an industry yet. That was something kind of specific to this project. Is that right?
Yes. The manufacturer's design, I believe, and tested it to that, but it had to be proven to get the variance at Forest Product Labs. They agreed to do the testing for us, and it proved its point.
Yeah. And one of the things we kind of touched about this a little bit is like the actual how that mass timber resists fire, right? So we look at that as like the char layer, but can you unpack like what actually happens and then like the impacts it has structurally, but specifically like for the fire department and like your opinions and I guess what you think
Mhm.
overall about that?
Yeah, I mean, it's a natural material, and as it gets heated up, it pyrolyzes. It off gases. It contributes to the combustion reaction, and then it starts to char. So naturally, it starts putting itself out. To use definitely firefighter layman's terms on that. Um, but it's like Mason mentioned, it is the contents that causes the fits and fires. I mean, if anyone listening to this takes a look around their office or their home, we have couches, TVs, everything, which is essentially gasoline in a solid form, um, you know, throughout our living spaces, and those ignite very quickly. They spread very quickly, and um, to a firefighter, regardless of the structural material used, whether steel or concrete or exposed mass timber, the heat coming out of these apartments, just say an occupant fleeing their apartment leaves their apartment door open, any approaching firefighters coming down that hall, even in all of our protective gear and our air masks and everything, um, an apartment fully involved in fire is an apartment fully involved in fire. It's going to feel pretty much the same. Um, rarely do structures completely fail in fires, but we're not worried about any structural collapse. We shouldn't have to worry about any structural collapse based on the natural performance of almost passive fire protection, in its natural construct. We don't have to concern ourselves with that, or if it's a steel. I mean, firefighters aren't thinking, "Oh, what kind of hangers did they use on this? Is this how'd they sink these beams into the concrete?" We need to get in there and put those contents out, and prevent those from spreading to the actual structure. What Mason also alluded to is, yeah, steel and concrete is not combustible, but it spalls. Steel at 1100 degrees is going to elongate 9.5 inches per 100 feet. So that's pushing out on that concrete. It's kind of destabilizing the connections and everything. Whereas wood doesn't do that. It for lesser, compression strength, it's not elongating, it's not pushing walls out, it's not going to, inherently just collapse based on fire. I mean, I don't want to say no way, but it's very unlikely that all layers of a CLT panel are going to be involved in fire or contribute to the fire, based on the char layer. So, that's a benefit. It's one of the things I talk about when I teach this stuff to firefighters is, you know, yeah, the sprinklers are going to put this fire out, but also the wood itself is going to start extinguishing itself and charring. Same thing at a campfire, we do with the alligator piece of wood. You pull it out and throw a new one in because it's no longer burning, right? It's not getting off heat, for your s'mores and your campfire. So it's the same in an apartment. So it has that same effect. Not to minimize it, but minimize, I should say. But yeah, so those are kind of the wins with wood, so to speak, for firefighters, is that we can kind of, especially the way these things are built and connected now and engineered within an inch of their life down to the last screw, we can have confidence that these buildings aren't going to collapse, and they're not the wood fallacy that the fire service is currently suffering.
What about I'm curious like how the failure mode of timber versus concrete or steel affects your guys' job. Like Mason, like maybe let's talk about like brittle or sudden failure compared to like a more ductile failure and like warning system. Is that applicable in this scenario?
It's something that's considered, right? As Eric said, concrete, when it's attacked by fire at a certain temperature, the heat makes the water bubbles inside the concrete boil, and that creates spalling. The spalling concern is then it exposes the steel rebar inside the concrete. As that rebar weakens and elongates, the combination system of a reinforced concrete beam starts to lose its strength and fail. Right? Steel is more ductile because you're going to get that elongation over time. We might have some localized issues that contribute to the failure. Wood, it's kind of improvement where if you see a consistent temperature, a steady temperature of burning, it's going to reduce the section as a consistent rate. And that's where a lot of our calculations are come from with the charring factors. The wood itself is going to, I think it's roughly over an inch of section loss per hour. So when the design end, we start doing the analytical method to figure out how large these timber beams and columns need to be to resist that fire. That's proven through a calculation method. And also, a lot of times we do require some kind of proof of concept testing. And there's been plenty of testing to validate that concept and my calculations real.
Got it. And so as mass timber is kind of like picking up, right? So I saw some figures late last year. It's like from the first mass timber building to today, plus or minus 700 projects built. Right now, there are, I think, 1 to 2 times that in active design currently, right? So like lots of pickup in mass timber buildings, and it's kind of spreading in different geographies in different regions. Like obviously, like West Coast, Pacific Northwest, very heavy with mass timber buildings, and it's the way I see it's kind of like moving, west to east. And Mason, you're in the New England area, and then Eric, you brought up like an article I'd like to talk about like New England, but specifically like NYC, right? Because like there's lots of conversations around East Coast mass timber, specifically in like heavy, dense urban areas. Like, what do you see in the fire world conversations right now around mass timber?
Well, the narrative's improving. It's not, because of the, being a mouthpiece for, the Ascent from the fire department's perspective, but a lot of these, the industry is getting the word out there. The science is getting out, the testing and it's finally hitting the mark in my opinion. So if you look at the city of New York, I did a lecture with the head of buildings for the city of New York. And at that time it was gloom and doom. The city and the fire department were like, absolutely not my backyard kind of thing. And I understood that. I didn't, poo-poo it. I didn't, I explained to him, I'm like, well, have you talked to them about mass timber? Have you shown them the metrics and some of the studies? And, they've seen it, but it was just, that overriding concern of like, do I want to put my name on this to approve one of these buildings, in Midtown Manhattan or something like that, or downtown Brooklyn, where, buildings are almost touching each other at 100 feet. And, at the time, the answer was no. And I brought along, this is the latest issue of WNYF. So what this is it's a firefighting trade magazine that's published by the FDNY. And in the current issue, there's an article on mass timber. And it's kind of a primer, so to speak, as to where mass timber is in the FDNY's involvement. They are now heavily involved in not just the approval process, but the research and code writing behind it for the city. And it's a promising article. I mean, it talks about, what it is. It gets into, kind of the, the SM 119 and some of that stuff. So, we're getting more aware in the fire service as to what this is. And, kind of the adage is, so goes the FDNY, so goes the rest of the fire service, right? They have a very robust billings and fire marshals division. The city has an army of code inspectors and enforcers. And so they have a lot of eyes and minds and, fingers doing research on this stuff. So it wasn't a mass timber is bad article by any means. It did leave out a couple things on water supply. Obviously based on wood, we need to have twice as much water to, put a fire out in one of these buildings than a steel and concrete one. But what the article doesn't have in there is the fact that if, we go over 120 feet in these buildings, you have to have dual water supplies, a fire pump at those heights. Conversely, a type 1 structure doesn't have those requirements unless the building is over, I believe, 420 feet. So the water is there for firefighters in these buildings. And, as, this stuff gets out and, kind of at the forefront of our firefighting, education and whatnot, I think, these buildings will be considered like any type 1, building in the city of New York or anywhere USA, in the near future. So I think the industry is doing a really good job talking about itself, getting the word out, and not only just seeing the aesthetic beauty of these buildings and the appeal of the natural appeal as you walk into these buildings. I don't think you're going to have the doomsday, kind of wood fallacies that we had, in the 80s and 90s. So, so step in the right direction.
Mason, what are the conversations like with peers and project partners on the East Coast like right now for you?
Yeah, East Coast has been a huge increase in the interest. Like you said, a lot of these projects started out in the Pacific Northwest. And that was a developed market because we were really close to sawmills and a lot of manufacturers. And the interest is probably double or triple now with projects in design and construction on the East Coast as it is in the West Coast. And then it's starting to fill in through the middle. I know the state of Michigan has a large interest in using engineered timber products because of their dense forests and the supply that they have, similar with Wisconsin, Minnesota, some of the Great Lakes states. We get up to New England, it's a similar interest. A lot of the projects we're looking at are in Maine, New York, New Hampshire, coming down into Pennsylvania, Virginia, states that have a lot of history with timber and timber products. And the people that live there are interested in timber buildings.
Based on what your firefighting background, your work with the Ascent, what advice would you give to developers that are going into markets that maybe are not as up to speed or comfortable with mass timber yet? Like what would you say are the best practices to make sure that everybody's like meeting each other's needs, that concerns are taken care of, and that buildings actually get built and move forward?
Yeah, I guess multi-pronged. I would first, invite the fire department right away. As you guys are proposing these buildings to municipalities, I understand the concern and the trepidation of bringing the fire marshals and building and code enforcement officials in, because historically, they might have been poo-pooed in the past and shut down. And I was recently in a meeting with some industry experts, and one individual said, well, sometimes fire chiefs and whatnot think they're the smartest in the room, and I was a little off put by the comment initially, but then I realized, no, I mean, he's, probably used to a lot of these projects being scrutinized, maybe over scrutinized, and, based on a lack of awareness or understanding or empiricism of this construction. But we're not there to be the smartest people in the room. Our job is not to stand in the way of economic development. Our job is to make sure the codes are enforced. We know what these buildings are, how you're building them, where the fire pumps are, fire department connections and whatnot. So really, we just want to be as informed as everyone else in the project. And again, we're not the smartest people in the room, but you also can't fool us. So we do know codes, we do know how most buildings are built, and we like to know how the rest are. So in addition, contact some municipalities that have these structures and talk to their code enforcement officials, and also look at the ATF and UL research on mass timber. And the ATF fire testing was, I think, seminal research into the how these buildings behave under fire conditions, and the forest product labs testing, and I mean in the manufacturers testing. I mean, obviously everyone burns their own wood and see how it behaves, and bring all those metrics to the meeting initially to say, here's the the materials we're using, here's the panels, here's how they behave, here's the testing we've done and whatnot. I mean, you'll have all that to talk about and look at. Explain that you are not going to have to, 99% of the time, you are not going to have to alter your firefighting operations to begin fighting fires in these buildings. It's going to behave similarly and or better in some situations than a typical type 1. I'm talking tall mass timber, based on variances and a lot of the stuff the fire department's going to have to say yes to. And, the fire departments, we're just part of the AHJ consensus. We're not, most of us aren't fire protection engineers, but, we understand what's required in these types of buildings based on IBC and code enforcement. So we're not gatekeepers. We can be convinced that these buildings are safe. Just show us. and we'll understand. Like I said, the fire service is a little slow to kind of catch up on best practices on building construction. You can correlate it to some type 4 legacy building fires that they've had in their regions, and explain to them the fire will behave better in those buildings because a lot of those buildings weren't sprinkler. If they were, they had these monster deluge systems, and that was up to the fire department to pump into. Newer buildings will have sprinklers every inch, and fire pumps, and a lot of active fire suppression. Cast in place concrete stairs that the legacy type 4 buildings didn't have. So all the things firefighters want in a building. So if you kind of explain that to them, keep them involved, let them come do site visits, check the building out, not just to kind of like do one of these to make sure there's no rubbish in the stairwell or anything like that, but to show them how they're built, to show them what exposed mass timber looks like, and how big these columns and beams are. Like I said in the beginning of our talk, I mean, our firefighters didn't gripe at all and say they stepped onto one of the floors of the Ascent. They just looked around, and it's just beautiful wood everywhere and monstrous surface area of this wood. And one of the questions I would ask is how much fire do you think it would take to wipe out one of these floors? And we're like, all the fire, right? So and that's how you convince firefighters. And word of mouth, our conferences, our lectures, and kind of our peer review journals I believe are going to start giving mass timber a fair shake in the near future. And that in turn will give developers a fair shake as well.
Mason, would you add anything to that?
May echo a lot of what Derek said there. Something that a lot of times fire departments find themselves being stuck in is, what is the developer going to dump on us and make us have to deal with for the next 15, 20, 30, 50 years that this building is here? As a design team, as an engineer, this building might be a season of a project for me, right? And then I'm on to the next thing. Same with the architect. The developers that don't build and then hold, the ones that build and flip, right? It's a season. It's a moment in time for them in their journey, where the fire department's left dealing with whatever is built until the building's no longer there. And that's been a lot of the concern. And Eric alluded to that, where when fire department's brought in at the end of the game, it doesn't have a lot of say. It's not a very collaborative relationship. And if you can bring the fire department in early, involve them in design, talk through and alleviate their concerns before dollars start moving, before shovels start digging the ground, and keep them involved as the building's built, that goes miles in developing confidence of a relationship that this building is MBC.
Got it. And if I could add one more thing, kind of, Bill, when you said he brought up a good point. I mean, we just don't like being surprised. I mean, you look at, some of the, tragic fires we've had, Grenfell in the UK, they had essentially styrene foam, exterior curtain walls put on this thing. And, what that does, in the recent fire in Hong Kong, where they had bamboo, exterior aesthetics on it, that is what's going to cause issues for firefighters, not necessarily how the building is put together or constructed. So, and those are the things that we really worry about. And, as mass timber, ages in the industry, I think, that's really going to be the focus, is how are you sealing these things, and, what are you putting on the outside of them, or interior cores or whatnot. So, we just like, being surprised by something cute the developer wants to do, so to speak. So, I think Mason nailed it.
Is there anything that we haven't talked about yet that you want to make sure that we do?
I think so. We talked about a lot of good stuff here.
Great. Thanks for being here with me today, guys. I appreciate you guys each sharing your perspective on fire and mass timber, how the design and construction teams are coming together with fire officials. I appreciate you guys being here, and I'm sure that we'll be talking with you guys again in the near future.